Hi everyone, welcome to our new video on image classification. Land use image classification using ArcGIS Pro. It's been a long time I haven't made any video, so let's see how to do that actually. So before we do that, at first we need imagery to classify that. So you can download Landsat or Sentinel level 1 data from. In the case of Landsat, you need USGS, while in the case of Sentinel 1 or 2, you will have to use Copernicus Open Access Hub, I think the name is. So then you have to apply some correction algorithms like radian value to radiance, reflectance, or you can directly download level 2 data, that is, already corrections are applied in this data, so you don't have to transform DN value into reflectance data, surface reflectance data. So that is done for you by them. But if you want to apply some manual correction algorithms, like flash correction, then you have to download level 1, use NV. So now before we head into the practical session, let's get acquainted with some of the terminologies of remote sensing, which is essential for you to learn. What happened? Yeah. So it's DN value versus reflectance. What is DN value actually? When you download a satellite image level 1, all you have pixels are represented as DN values. Now, DN could be different between two cameras. Now, I have here written down some of the comments of some researchers. Alright, so this is by one researcher. He said DN could be different between two cameras for the same target. So the DN is with instrumental characteristics, but the reflectance is not that. It's a property of the target which is supposed to be not changed by different instruments. All right, so it's safe to use reflectance data. Then another person said data in DN is singular, whatever it is, so that different dates should not be compared. So he said that actually if you are using comparing multiple date images, then you shouldn't use DN value. So now right here another person said, is it, the same thing that I said, using single date, then reflectance, radiance, same thing. So in conclusion, I would say use reflectance data. That's good. Now let's talk about radiance. Radiance is the amount of radiation coming from an area. That's it. It has a unit. While reflectance is actually ratio. That since it's a ratio, so it does not have any unit dimension. Reflectance is a proportion of radiation striking a surface. So let's say surface striking radiation is X, while radiation reflected back is, let's say, Y. So that's the reflectance. Unit is same here, unit is, let's say, this one, unit is this one. So when you divide, same unit, no unit. Then in the case of reflectance, there are two types of other reflectance. One is TOA. You will see that in Google Earth Engine, Landsat 8 TOA data. So top of atmospheric reflectance is the reflectance measured by a space-based sensor flying higher than the Earth's atmosphere. So it does not exclude atmospheric problems like aerosols, gases. So for that, you need to apply a different model to reduce those effects, that is surface reflectance. After that, you will get surface reflectance. And surface reflectance is devoid of clouds and effects of clouds and atmospheric components. Now, to achieve surface reflectance data, you have to apply a model. I think it's called inversion modeling type things. So you can use either NV. NV has a flash algorithm, Then you can use, I think, AirDAS also provides that. Then QGIS, free software, open source. ArcGIS does not provide any correction algorithms, I mean modeling things. So ArcGIS is not a suitable option in this case. Alright, now converting Landsat 7 level 1 data into TOA radians. Just one example, a formula you can say. So you can easily do that in ArcGIS manually. Radians, converting um, DN value into radians. Then converting radians into top of the atmospheric reflectance TOA. So you can see L lambda. Here you can also see L lambda actually. So in the case of Landsat 7, conversion of DN value into radians is essential because the next, I mean for the output of reflectance, if you want to work with TOA reflectance, then you obviously have to at first convert DN value into radians. But in the case of Landsat 8, it is not the case. You can directly convert DN value into reflectance value. Okay, sounds good. Now let's talk about imagery download actually. In the case of Google Earth Engine, you can directly download, access level 1 TOA data. TOA, that is surface reflectance. No, not surface, top of the atmosphere. But in the USGS, I think you will not find that. So you will download level 1 data from USGS. And you can also download level 2 data if you want. So let's see how to download. No, discard. So at first you need to head over to USGS, Art Explorer, then log in. I think you know that already if you have done it before. Sign in. It's taking some time. Yeah. Now you need to go to the place where you are interested. You can either search here or just navigate to the place of your region of interest. Let's say I am interested in this area. I actually some days ago worked on this region. So just click on your region of interest, then come here date range. So let's say I am January 2023 1 up until February 28. Then cloud cover, let's say I'm not actually filtering by cloud cover. Let's see what we can get. Data sets. Now land cover, you see, no land, not land cover, Landsat. You can see Landsat collection 2, level 2. If you want level 1 data, then you will come to this one here. Here you will see Landsat 8, 9, even you can get 9 now. Now you can click on additional criteria or results. You can see the scene, you can also see that there's no cloud coverage actually. So a fresh one, if it matches your desired date, you can download it by clicking in this download icon. So this is actually level 1 data, and level 1 data you can easily identify by just seeing its name. You can see LC8, that is 08, that is its Landsat 8 image. L1 means level 1. In the case of level 2, it will be L2. Alright, so go back. Oh no. Well, fine. I thought I would show you about level 2 data, but you can figure it out, I think. All right, now we are coming back to ArcGIS Pro for the next work. So at first what you will do, you'll add folder connection, then you will head over to the folder where you have stored your satellite image. I have already made those TIFF files, but maybe you haven't done any composite. So go to geoprocessing pane, then write composite. I think it's, yep, composite bands data manager. So double click on that. Then input data, you can directly go to the folder where you have stored your satellite images. I think level 1 data, level 2 data is here. You can say L2 SP surface reflectance. I don't know. So I would, here we are. This is band 3. This is band 1. So 84 kV. And this one is, so let's say we will load up until band 7. You can say 83 kb, 83 megabyte, I think it's. So from 84 to 83, click shift, and yep, band 1 2 3 4 5 6 7. Then you can write a name or just run. You can specify folder, in which folder you want to store. Also you can do that. That's it. So it's taken some time. I have already made that TIFF file here. Also I have cropped that image for my desired location. You can see here. So it's a 30 by 30 image. If you right click on it, go to properties and metadata or source, define band statistics, raster information, columns, rows. So from that you can calculate, I think, how many pixels are in it. 194 multiplied by 168, that's it. Cell size 30. So by multiplying the pixel sizes by 30 into 30, you will also get the area of that image, how much area it covered. 16 bit, that's Landsat image. Band spatial reference, I think it's in UTM zone, UTM 46. Yes, UTM 46. It is projection system, and it is coordinate system, geographic coordinate system 1994. Fine. Alright, so we have the metadata like information. Now before, when you are going to apply some mathematics or processing on this image, you have to at first select this image, this one. Then you go to imagery. Now you can see a lot of tools are available for this image. If you would like to calculate any index, let's say NDVI, you can click on it. Yeah, our composite band is ready. So now NDVI band near infrared for the Landsat 8, near infrared band is 5 and red is 4. Now how do I know it? You can just search here Lands 8 bands. See, band 1 2 3 4. 4 is red and the following one is actually, if you click on it, you'll find that near infrared. Alright, you can click OK. Now you can see NDVI image for that area. You can then export it, zoom to layer this image. This image was a bit of cloudy, but fortunately my study area was not cloudy, so it didn't matter. So right now you can see after compositing that image, it's a bit dark. So what you can do is you can raster layer, go to raster layer, you can go to symbology, or you can right click here, just change band combination, symbology. You can go from here, symbology, RGB, stretch. What is this happening? Holy shit, I have deleted it. Anyways, what you can do is zoom to layer, right? Yep. You can come here, you can, if it's dim color, you can try different stretching methods like percent clip. I am right now in percent clip mode. You can try standard deviation. Now you see the appearance have changed. Histogram equalize. I mean, you can apply multiple methods, but percent clip works good for me. Also, you can click on this DRA tool. So now when you zoom, it will zoom over region. It will adjust brightness for those area, for that area actually. You can uncheck it. So now regarding band combination, you can, when you double click on this, you will find here symbology. If you don't find that, go up raster layer and go to there RGB, etc, etc. So right now it's in 543 band combinations. You can go to true color 431, I think 432, sorry, RGB, red, green, blue. So that's true color image. That is going to be look like if you see this area over a plane. Now in the background I have opened actually uh, a base map, satellite image base map. You can see here imagery hybrid, so you can click here, that will work for you. Now you can see the area, like what's the you can see this is actually a built up area. The background image is not good actually. This is also a built up area right here. So now we are going to actually do a classification on this image. You can also use different band combinations. You can save it right here. I have saved 654 here. You see, whatever it is, are blue or dark. Now let's come to imagery, then classification tools. What you need at first is training samples. For supervised classification you need training samples. So click on training samples. Then you'll find this window will pop up. Here you can see it's called schema. Schemas are nothing but your land classes, how many classes you are going to have. So we're not going to use this schema. We don't have this such, I mean, classes. So we want new one. So you can say create new schema. Rename it at first, but you can rename it when we are going to save it. So add new class. Let's say we will have water value. This is important, it has to be unique for different classes. Let's say one, watercolor blue. We are going to use less number of classes. Let's say at first we'll try with 3 classes to reduce our time, I mean to make it quick. It's not underwater, you need to right click on there, up in the new schema, then add new class. Now it's page. Now we have here mud flat, built up, color is whatever it is, no problem. Just change this color. That's it. So these are actually salt pans. Maybe you don't know what are salt pans, how it's look like. These are actually salt pans. If we go to Google Earth Pro, then it will be more visible to you, more clear to you. It's and this one is actually mangrove forest. These are mangroves. Here you can see we have a lot of mangroves right here. Now, now the time is to collect our training samples. How can we do that? By here you can see these are the tools to collect our training samples. Let's say we'll use circle. We have clicked on that circle and we are going to collect samples for water. So we have also clicked on water. It's important. You have to first click on the class you want to take sample. Well, then this is water. Very big samples are not good, I think, telling from experience. This is also water. Now if by mistake you take wrong sample, let's say this one, then you can come here and select this one, then delete this sample. Easy peasy. Alright, then we have more water right here. Oh no, it's not taking that small sample. So for that we are going to use polygon tool. Mhm. This is water. Alright, now let's merge all of them to one single for convenience. So you can now see all those samples are selected. Now if you click on it, all of them are going to be deleted. You need to take more samples, but it's not essential to take more samples. You need to take actually qualityful samples. If your samples are not qualityful, if your samples are with with outliers, then the classification will be bad. Then vegetation. Let's say this one vegetation mangrove. Circle is easy. So these are vegetations. So that's it. We are not interested in more samples. Then build up. This area is actually built up. This one is also built up. You can see built up, red. Then we have some built up here. Yep, that's it. We're not taking any more samples right now. Then we have salt pan. I'm taking a very small number of samples. Actually, I have already taken a huge sample set, not huge, but a bit of sufficient. I will show you that after we are done with this one. So let's say these are salt pan. It's actually matte flat, not salt pan. These are salt pan. Here we have also salt pan. This one is matte flat, but we are assigning those things to same class. All right, our sample taking is. Oh, we have missed one essential class, that is cropland. So make another class. CROP. Okay. 5 classes. This is agriculture. You can also check that by seeing the background image. This one is agriculture, you see. This one as well, I think, is agriculture. Yeah. Alright, we're done with taking samples. Now the task is to save those samples so that we can reuse it. So now, save as. I have already taken some samples, saved that. Let's say this one new. Let's say sample saved. It will be saved as a shape file. Okay, then now we are going to classify our image. By what? By using classification wizard. Supervised. When you click on classification wizard, then you'll find this one. Or you can directly do from classify, you see. Classify pixels. Supervise classifier. K nearest neighbor, support vector machine, maximum likelihood random forest. But I generally don't use this one. I use this one, image classification wizard. So here you have two options, supervised or unsupervised. We're going to use supervised. Then object based or pixel based. We're going to use pixel based. Up next we'll see object based actually. Object based, and depending upon the satellite image you're using or the level of detail you want, object based is better one when you have good resolution images. Classification schema. So we have we no, we didn't actually saved our schema, but we could have saved our schema as well. How? If we go to training samples manager again, oh yeah, it's already there. So now you can save it. So here you see saved current classification schema. What is this one? Yeah, save. The name is test schema. This one is important. Yep. Okay, we already have name actually. Save. It has been saved. Now you can go to classification wizard. Then browse to existing schema. You can generate schema from training samples, or you can go to your. Right now we have just saved one schema. Browse to existing schema. You can go there. You can see here I have a lot of schemas right here. So new schema. What was the name? Test, I think. It was in another folder. Mohashkal, I think. Right here. Yeah. You should find that schema right here, but at first you will not see this one. Now to see that schema, you need to now shut down your ArcGIS Pro, then again open your ArcGIS Pro, then you will find it. So that's why for convenience I am going to use some of my existing schemas. Alright, but we can do another thing, generate from training samples, but I am worried that yeah, well, we don't even have that training sample here. For that you need to restart your computer, and not restart actually, you need to close your ArcGIS Pro, then again open it, then you will find your data right here. So let's say I am going to use our previous one. So we are going to generate schema using our training data. Then go to training samples. This one is our training samples. Then click next. Now you see all the samples appeared here. Here we have more classes, 2, 4, 6 classes. Fine. Then click next. Classifier. Which classifier would you like to use? Random forest is good one. Here we don't have random forest, we have random trees. I think that's the same thing. Random forest tree. Yeah. Maximum number of trees. um, maximum tree depth. Let's go with the default. Then run. It's running fine. We have red one is actually settlement. Here we don't have any settlement, but we have some sandy area here. So since we haven't made any sandy class, sand like class, so it grouped that class inside settlement class. Anyways, if you are not happy with this classification, let's say you need more sample, then you can come back and again take some samples. All right, now you can, let's say agriculture, you want some more data for agriculture, you can also do that. Fine. Where is it? Yeah, but you can't save this new data, I mean new added samples, you can save it. So next, again run. Fine, let's say you are happy with this output, let's say. Then you click next again. Output classification dataset, fine. Use classifier, no. Run again. This is going to be, I think, our final classification. This is just preview. Now we see final classified image. Then go to next. We have more options. Give it some time. Merge classes, okay, fine. You can even merge different classes right here. The next. Taking some time. Yep, this one is actually, I like it a bit, because let's say for example you want to force this red one into green. I mean this is, this is not settlement. Now you want to convert this red one into, let's say, agriculture. How can you do that? So you can see reclassify within a region. Select that. Current class is red, that is settlement. It's important. New class, you want new class to be agriculture. Then you need to select that region. Let's say this one. So it will force this region to be agricultural land and not affect your other regions. That's a good one. Now you can already see the preview. You see, red one converted into green. So then you can try that with multiple things wherever you like. All right. Then what? Sorry, I don't need this one. Let's say this one was by mistake. So here you can see your samples. You have two samples. We don't need the last one, so you've unchecked this one. Settlement to agriculture. Which one is? Yep. So we don't need the last one. So fine, then run. This is going to be the last run. After that you will not have any options to change this image. So reclassified, yeah, we're done. Reclassified image. Finish. Yeah. Now you see that red converted into green with a bit of noise. Anyways, so to reduce this noises, to make it a bit more impactful, you need good quality image, also good samples, and you can also mask out some unnecessary pixels. Like you don't want any sandy areas in your data, so you can mask out those pixels. That's good practice. so there will be less interference with other pixels with our other classes. So that's it for regarding supervised classification in ArcGIS Pro. Now you can also import your existing, let's say, shapefile as a training data. Let's say you collected some training points using Google Earth Engine. You can also import it right here, but for that you need to have two columns essentially. Let's see what are these two columns. I think I'll, maybe if you guys need that, maybe I'll upload a separate video regarding that. But the essential columns are these. Let me show you actually. Your data, I mean your shapefile must have, as far as I am concerned, a class value and class name, two columns. And you will be clear about it if I open one shapefile, I mean the training shapefile. If you see that structure of the training shapefile, you'll get the idea what type of, I mean which two columns, three columns is essential to include your previous shapefile as a training shapefile. So if we go to where are our training samples located? I don't know. So that training comes in actually. So that's it for now. If you have any queries, you can let me know that in the comment section. Thank you for watching.